Okay, so let us continue. For the one who was asking about ionic bonding and the criteria for electrons, if you have an atom with 1, 2, or 3 electrons, and another one with number of electrons, let's say higher than 5, then in this case you'll have ionic bonding, because the one with 1 to 3 will tend to lose, and the one with 5, 6, 7 will try to gain, and in this way you will have an ionic bond. Okay, is this clear? Now we will do it in problems also, it will be clear. Any
Yes,
other
it's clear,
question
Doc.
before I move to the second question? Okay, so now which of the following bonds will be ionic? So they gave me several possibilities, and I should know if the type. Do you hear me now?
I can hear you there.
Doctor, I can hear you.
Okay. So for H and H, okay, we have seen together that H has only 1 electron on its outer orbit. So if I illustrate H, okay, so H has only 1 ion, 1 electron, sorry. So if I have 2 atoms H and H, what they will tend to do?
They will share the atoms.
Yes, of course. They will share their electrons, okay, to reach a stable set, okay, of 2. So when I have H with H, they will share their electrons together and will form the molecule H2, okay? So it will form H and H with a covalent bonding in between. Now, the other 2 atoms, oxygen and Cl. Again, I will go to the periodic table. So going back to my periodic table, which is here. Do you see now the periodic table?
Yes.
Okay, so the 2 involved atoms are oxygen and Cl. Okay, and as you can see, both has high number of electrons on their outer orbit. You know how you can know it? You can know it from the group, okay? Because in the periodic table, they arrange the atoms in a way to have common properties. So all elements of group 1 will have 1 electron on their outer orbit, okay? And for group 2, all elements will have 2 electrons, etc. So here, for example, oxygen is in group 6, so it will have 6 electrons on its outer orbit, and you can know this directly from the atomic number, because the atomic number is 8, so 2 electrons will occupy the first orbit, and the remaining, which is 6, will occupy the second orbit. Now for Cl, Cl is in group 7. Okay, so it will have 7 electrons on its outer orbit. So as you can see, both relatively have high number of electrons on their outer orbit. So we said that when the atoms have high number of electrons on their outer orbit, they need to do covalent bonding. So of course, between O and Cl, it will not be an ionic bonding, it will be a covalent bond. Okay, so this is, so you can directly say, if you want to respond to this question, you can say, since both O and Cl have a high number, you can say valence electrons, because the number of electrons on the outer orbit, so have a high number of electrons on the outer orbit, so which are called valence electrons. Okay, then they tend to form covalent bonding together. And if you want to put the molecule that will join O and Cl, how it will be? You have oxygen. So for oxygen, if you draw the Lewis structure, it is like this. You have 1, 2, 3, 4, and 5 and 6. While for Cl, okay, Cl just need to share one electron, okay, because for Cl you have 7 electrons on the outer orbit. So what will be the resulting molecule? Who will tell me?
OHCl.
What?
OHCl.
OHCl, or if you want to have only O and Cl without H.
OCl2.
Exactly, very good. OCl2, okay? Because you will have one Cl will share one electron with O, and another Cl, okay, will share another electron with O. And in this way, you will get the molecule OCl2, for which all atoms will have a stable set of 8 electrons on their outer orbit. Okay, so that's it. So of course, here the type of bonding will be covalent bonding and not ionic bonding. Now, moving to the third part, you have
Doctor?
NAF. Okay, so for NAF, also I will go back to the periodic table. Let me check if you have questions. Okay, so yes, Karim, both are non-metals, so they cannot have a metallic bonding. Okay, and they will not form an ionic bonding because, as I told you, both tends to gain electrons, so no one is tending to lose electrons. For part A, it's covalent because each H will share with the other one electron to give you H2, the molecule H2. Okay. Now, for part C, for Na and F, if I go back to the periodic table, okay, you have Na is in group 1. So because Na is in group 1 and F, it is here, it is in group 7, here I will have an ionic bonding because Na will tend to lose 1 electron, while F will tend to gain 1 electron to form ions Na+ and F-, which will attract each other. Okay, so here, this is the condition to have an ionic bonding. One atom should be ready to lose electron, so it should have a low number of electrons on its outer orbit. So as I told you, 1 or 2 or 3, while the other atom should have a high number of electrons. So here you have, for Na, it has 1 electron, which is a very low number, while F has 7 electrons on its outer orbit. So by losing 1 electron, Na will reach a stable set because it will have 10 electrons, so only 2 orbits. And F will gain an electron to have now 10 electrons and will reach a stable set. And in this case, you will have the formation of ion Na+ because it has lost 1 electron, and F will be F- since it will gain 1 electron. So the resulting compound will be NaF, which is a ionic compound, or we can write it as like this, Na+ F-. Okay, and this is a strong ionic bonds are stronger than covalent bonds because they involve opposite charges. And you know that when you have opposite charges, you will have creation of electrostatic forces that will attract the atoms together. So this is why in general ionic bonding is stronger than covalent bond. Question on this? Low number of electron and 1. Yes, so here you have 1 metal and 1 non-metal element. Together, they will form an ionic compound. Exactly. So as you can see here, you have the metal zone to the left, the non-metal zone to the right. So in general, ionic compounds can be formed by combination of a metal and a non-metal, because the metal tends to lose electrons while the non-metal will tend to gain electrons. Okay. Now for we still have C and in part D you have C and N. So for C and N, I go back to the periodic table. Okay, this is C and this is N. So as you can see, both have a relatively high number of electrons, higher than 4. So for C it's 4 and for N it's 5. So of course they will tend to do each other covalent bonding and not ionic. And the final two atoms are CS and F. So for CS and F, as you can see here, this is CS. CS is from group 1 and F is from group 7. Okay, so it's like the other example here. It will be an ionic bond because CS will tend to lose an electron to give the CS plus ion, and F will tend to gain the electron to give F minus electron. So here you will have attraction between the opposite charges, which will form the compound CSF, which is an ionic compound, CS plus and F minus. One final remark, okay, for ionic bonding, you can have, for example, if you have an atom of group 2, like Mg, it can combine with an atom of group 6, because an atom of group 2 will tend to lose 2 electrons, while an atom of group 6 will tend to gain 2 electrons. So one possible ion compound will be Mg2 plus, okay, and S2 minus. And on the other hand, for example, if you have Mg to connect with Cl, how much atoms you need? How much Cl atoms should lose their electrons to form a compound with Mg?
2.
2. Very good. Because Mg can lose 2 electrons, while Cl can only gain 1 electron. So we need 2 atoms Cl to be in ionic bonding with Mg. So we will have the following. We will have Mg, in this case Mg2 plus, okay, and with 2 Cl minus, okay, which will give you MgCl2, which will give the compound MgCl2. Okay. With the other group, I was able to do an additional number because the number of participants in the first class is much lower. So what I will do, I will continue with you next time with problem 3. Okay.
Okay, doctor.
So we continue the problems next time.
Thank you, doctor.
Welcome.
Thank you, doctor.
So, doctor, next Wednesday we have a session.
Yeah, we will continue problems on this chapter.
مش
Alright.
هالوينزداي
نعم.
مش هيدي الوينزداي او اللي
بلا
بعد
هيدي الوينزداي أكيد.
اوكي
Okay.
thank you.
Doctor, I have a question.
Yes, tell me.
The chapter 1 هي تبعت لي introduction. So slide 21, you were talking something about casting and the percentage numbers. Should we know them or you were just saying general numbers?
Look, you just should know it as an application, but the details of casting will be studied in a chapter after. Okay?
Okay.
So you just need to know it as application, as we were talking about it, but you do not need to go in details.
Okay, doctor.
Okay.
Thank you.
Welcome.
Bye, have a nice day.
Bye bye.